what we call big moments in the exhibition, and this is the first one. So what you're seeing here is you're seeing artistic representations of real bacteria found on Earth that live in extreme environments. So they're called extremophiles, which you may have heard of. Don't ask me which ones are which, because I'm not a biologist, but this was done in conjunction with our colleagues from the Open University, who helped us with some aspects of this exhibition. And these are, as I said, it's sort of artistic interpretations, but it's based on real imagery of different types of bacteria, as I said, that live in very harsh conditions. So very dry places or very hot places, places like the acidic lakes in East Africa, and also as well, believe it or not, nuclear reactors. So these very, very tough bacteria that have evolved to live in these harsh environments. And by understanding more about this type of bacteria, we can actually understand how you could get similar types of life forms perhaps existing elsewhere out in space in these similar sorts of harsh environments that even, 30, 40 years ago, people did not think you'd be able to get things living in these harsh places. So just to give you again a sense of the exhibition, what we're trying to do is take you on a bit of a journey through space and time. So we start off in the early Earth and we'll progress as we go through the exhibition, both in terms of the solar system and elsewhere, and also potentially to the future. So we're in the Earth zone. There's several things in here that I'll point out. You don't need to listen to me which are on, so I'll give you some highlights and then you can obviously have a look round and you can ask me any questions. So this is a slice of an iron meteorite. This is from the core of an asteroid, early material in our solar system that tried to form a planet but didn't quite make it. This is a slice, it weighs about half a tonne of a much larger meteorite which weighs about 13 tonnes, which is actually in Australia, but this is a slice of it that was gifted to us from our friends in the Western Australia Museum decades ago. So you can touch that. You can also touch a piece of the Allende meteorite. That is one of the oldest objects that we know of and predates our Earth by about 150 million years. So it basically dates the start of the solar system. We've got some other meteorite types that you can have a look at. There's instruments in the case, there's information in the cases. Please do go and have a look at the Winchcombe meteorite over there and the driveway that it landed in. So that was an interesting conversation I had to have with our then Director of Finance. Please can I have some money to go and chop up the driveway and bring it into the museum and then obviously make it good. And then there's some amazing other specimens around the corner which I'll tell you about when we get round there. But please feel free to have a look around. Yeah. Very, very generous. They helped very ancient fossils from the Earth. These are things called stromatolites, and they are basically sort of fossil algal mats that build up, say, at the edges of lakes or sometimes sort of like seas as well. So you get these warm lakes and you get this algae forming. They form this protective sort of rocky mineralogical outside, and that can be preserved in rock. And if the rock is not changed too much, you can get these preserved over millions of years. In fact, we've got some sort of quite new ones around there, and in fact ones that you can touch. Now, these are all very old stromatolites that date some of the oldest evidence of life we have on Earth. But this particular sample at the bottom, this is a rock from the Dresser Formation in Australia, in Western Australia, a place called the Pilbara that you might have heard of. And we did some work on this, probably about 3 or 4 years ago, and this is actually the oldest confirmed evidence of life on Earth. So there's lots of arguments amongst scientists, is it really evidence of life, or could it be this? This is the one that everyone says, yeah, that is evidence of life in this one here. It's from the Dresser Formation, number 1. That one there. Sorry? So very simple. So algae. We've gone from the early Earth to asteroids. So we know that there are certain things that you need for life. You need to have the right type of physical environment. You need to have the right sort of chemistry. You need to have a protective layer, and you need to basically have sort of time for things to happen. So the reason why we've moved on to asteroids is we don't think asteroids have got life on them, but these have the chemical precursors that you need for life. And we know that the early Earth, and indeed elsewhere in the solar system, was bombarded by asteroids in the first about 500 million years of Earth's history.
Now found all the essential ingredients.
They have, exactly. So all of the essential amino acids and other organic molecules that you need for life to start have now been found in meteorites. So it's not that there's bacteria or viruses or bugs or anything in the meteorites. They're delivering all of that chemical stuff you need for life, including, weirdly, water. So we think that Earth got its water probably from asteroids and or comets, and there's a bit of discussion about whether it was more asteroidal, more cometary, or a bit of both.
And the impact of asteroids absorb those ingredients.
Exactly. So the impact, so that those asteroids were seeding the early Earth with all of those ingredients for life. So we were very involved with the recent NASA mission, OSIRIS-REx, which went to the asteroid Bennu and collected samples that were then returned to Earth. So we were involved in the preliminary examination of those samples. You can smell what an asteroid smells like. I think it smells a bit like an aftershave I've smelled before, but gone wrong.
I said my grand's coffee.
Oh, there you go. So yeah, we're in the same. You'd wear it, yeah. And then one of the things that was quite surprising, although not unexpected, was actually when the sampler touched down on the surface of the asteroid, it was much more rubbly and quite sort of squishy than maybe some people had anticipated. Although a lot of tests were done by the company that made the actual spacecraft, including this is actually a test sampler head. So this is not the real one because that's actually at NASA, but this is one of the prototypes. And this was actually tested on NASA's what's called the Vomit Comet. So this is the plane that does the parabolic flight. So you get a few seconds, I think about 30 seconds or maybe 45 seconds of zero G and low G. And this was actually the one that they were testing on the Vomit Comet to see that it would actually work and collect material. And this is also one of the parachutes. They also dropped sample return capsule models in the Utah desert to see that they could actually land safely. So that's actually one of the prototypes. This is one of the parachutes that was used. And in fact, when we unpacked it, we got loads of Utah limestones with dust and sand and stuff. So hoover it all up. Cool. We also have, actually I should point this out, but it's a bit difficult to see unfortunately. In this container here, we actually have a tiny piece of asteroid returned from the Japanese space agency Hayabusa 2 mission that went to an asteroid called Ryugu. And these are objects on loan from the Japanese space agency. These are 2 little hopper robots, so they actually hopped around the surface of the asteroid. They were able to do that because it's very, very low gravity, so they can hop, and it's actually a more efficient way of doing that on an asteroid than driving around. And that's actually one of the images that these little we call them rovers, even though they haven't got wheels. The Perseverance rover and the Ingenuity helicopter. There'll be a dust devil. There'll be a dust storm. We're now going into the Martian night. We'll see the moons of Mars, Phobos and Deimos. We might also have a meteorite impact. And then you can also actually go up to the panel and see, go back in time to see what early Mars was like.
Yeah, but that's the thing when you
icy moons of Jupiter and Saturn. So these are moons that we think have got these liquid oceans under the surface and protected by an icy crust, and that's why ESA and NASA have been sending missions to those places to really go and look for that evidence of life and potential life. So we have a model of the JUICE spacecraft. This is the Jupiter Icy Moon Explorer, which is an ESA mission. And we actually have some test instruments that are actually on that mission designed by colleagues at Imperial College just next door. We also have a model of the Dragonfly mission. This is a mission, a NASA mission that's due to go and visit the Saturn's moon Titan, which is a really interesting place. And we have actually one of the test rotor blades that has been used by NASA in their wind tunnels to work out how it's going to work. And we also, you can design your own space mission to the outer moons if you want. If your mission fail, we'll be able to answer the scientific questions. And then again, we have some actual real specimens from our collection. And these are, I think, pretty grossly around ocean vents, these volcanic vents, very deep oceans. And it's really just to show that even, sort of in the 1960s and 70s, in those depths was too deep, pressure was too high, there wasn't any sunlight. How could life live there? In fact, life is teeming in some of these places, and it's evolved to be able to live under these harsh conditions. So you can have a look.
was there an see the event Titan? Was there an idea to get you
Yeah, so, no, so what's really cool about Dragonfly is it's actually going to land. So both JUICE and are doing two missions. Yeah, exactly. Yeah, well, it is, yeah, so Europa, exactly, it's got these like really always dies at the surface, and that was those I think were first observed. It was either, I think it was the Voyager mission, places outside our solar system, so other planetary systems that are in our galaxy. So using instruments like James Webb Space Telescope to actually observe these exoplanets and work out, are they in the habitable zone around their star? Do they have the right sort of characteristics that could actually support life? So this is where it's getting into more the unknown, but it's still tantalising. And we've even actually got it's not a model, it's actually a real one. So you might have heard of SETI. Have you ever seen the film or read the book Contact? So SETI is the search for extraterrestrial intelligence. So if you've seen Contact or read the book, you know Alan Arroy's radio signals. So SETI still do that, but they have developed technology now which is laser flashes in space, because we had advanced civilizations, they'd probably be using lasers for communication, they'd be using lasers potentially as propulsion. So if you start seeing laser bursts, that could be actually an indication. So they've now got this thing called laser SETI, and they're setting these up around the world looking for...
How wise is that?
How wise is it?
Yeah.
I suppose it depends on your point of view.
Stephen Hawking thought it might be about doing it.
Yeah, I mean, I'm fairly agnostic to be quite honest. But it's, you know, it is an interesting concept, and in fact we have a little interactive over in the corner where we ask visitors different questions, like, you know, if we found, you know, if we heard a signal, what should we do, or should we be sending out stuff, you know, or if you found an alien, what would you want to do with it? Would you want to eat it? Would you want to study it? Would you want to kill it straight away? So it's been something else to be quite interesting.
Can we send those lasers ourselves to the other universes?
So my understanding is, now I'm not an engineer, but do you remember at the beginning I said we worked with our colleagues from the Open University, the astrobiology group? They also helped us with this, and this is where we imagined different types of planets elsewhere in the galaxy. Maybe a very watery planet like an ocean world, like one of the icy moons of Jupiter or Saturn. Maybe a planet that has a very thick atmosphere, things like that. And we imagined what type of life forms. So we have 4 different life forms. We have a carnivorous plant that uses light to attract its prey. So like an anglerfish would use light. This actually uses light to attract its prey. My favourite one is that one, which is a shrimp that lives again in a deep ocean on a planet. We call it moustache shrimp. It's got one eye, it's a cyclops, it's got a little moustache. And then we also have a crab that lives along with the shrimp, he doesn't have any eyes because he doesn't need them. And we also have, the last one is a bacteria, is a colony of sort of floating bacteria, almost a little bit like plankton that live in a gas giant world and basically live by floating around in the atmosphere. So if you stand on the circles of light, you'll be able to see these beautiful depictions. But as I said, these are imagined, but they're all based on sort of science. We're not exiting through the gift shop, although it's very good, so you have to come back and buy things in it. My friend and colleague Lucy is gesticulating, so we're going to go out of that door. Welcome very much to the Natural History Museum. I'm Professor Caroline Smith, and I'm the lead scientist on our wonderful space exhibition that you've just been visiting, so Space, Could Life Exist Beyond Earth? But tonight we've brought you here, our very valued guests, to see a special display with Disney Plus for their upcoming series, Alien Earth, and as well as treating you obviously to the tour that we've just had of our exhibition, Space, Could Life Exist Beyond Earth? Disney's 8-episode series opens to a deep space research vessel, the USCSS Maginot, crash landing on Earth. It follows Wendy and a ragtag group of tactical soldiers as they make a fateful discovery that puts them face to face with the planet's greatest threat, raising the question, what if they're not alone in the universe? Now, as a science research centre here at the museum, we are also asking big questions like, is there life elsewhere in our solar system, or indeed the wider universe? And this is a key question that humanity has always been interested in. If you think about cave art and early art depictions of space, people have been fascinated by the cosmos for years. So it's a really wonderful opportunity for us to partner with Disney on this amazing new series that they've developed, which we hope will really capture your audience's imagination and share this journey of discovery with us.
So it's the first time in the museum's 144-year history that we've actually had an exhibition on space, and we've been really delighted to share it with you tonight. So you saw some of the samples in the actual exhibition of our meteorites collections. We've got one of the best meteorites collections in the world, and we're also working with several international space agencies, notably NASA and the European Space Agency, on designing and operating missions to try and find out those fundamental questions of are we alone in the solar system. So, just as we are pushing the boundaries in the search for life, we're also pushing the limits to bring you closer than ever to the action. And as I said, you will see a very exciting specimen imminently. You've seen prototypes from different space exploration missions in the exhibition, including ones that I'm involved with. So I mentioned to my group, I'm working on the Mars Perseverance mission, and these are really important missions that are looking for those tantalising evidence for the precursors of life or even life itself today. So from tomorrow, and for a limited time only, fans and visitors will have the chance to come face to face with a xenomorph egg, the spine-tingling relic from Disney's new series. And this is going to be actually positioned opposite the entrance to our space exhibition, Space Could Life Exist Beyond Earth? We are genuinely very, very excited to have one of the most iconic depictions of alien life displayed outside our exhibition, and being able to link it to the work and our stories that we tell in our space exhibition. But just tonight, for you, our honoured guests, the veil is lifted, and it's lifted early. You're getting a sneak peek. You are going to be the first to witness this otherworldly artefact. So step closer and ask yourself, could life really exist beyond Earth?
This is so cool.
Very cool.
Randomly, I got on the release of the most. So good.
Actually, I'll just get a detailed document.